All right, hey AP Chemistry, for these next set of questions, these come from section 6.3. And so there are going to be some equations that you're going to have to summarize or get, and these are known as the gas law equations. So this is P1 V1 equals P2 V2. We call that Boyle's law, and it means that pressure and volume are inversely proportional. And everything else is pretty much directly proportional. V1 over T1 equals V2 over T2. This is Charles' law. Volume and temperature are directly proportional. P1 over T1 equals P2 over T2. This is the Gay-Lussac's law. Pressure and temperature are inversely proportional. We have Avogadro's law, which says that moles, N, and volume are directly proportional. And then we have this combined gas law that we could use later, but I could combine all of these equations and I get what's known as the combined gas law. And these are just equations, and this is just like a nice shortcut, but these are just equations I could use to plug in any of those values and solve for an unknown. And then side note, temperature must be in Kelvin. Not sure if you remember this from honors chemistry the previous year, but degrees Celsius versus volume, if this is a degree Celsius in volume, it doesn't go through zero, but once I get it to go all the way through zero, Kelvin and volume goes through zero. So this proportionality of temperature and pressure and temperature and volume only works with Kelvin. And if I want Kelvin, I have to add 273 to my temperature. So we could use any of these equations for these questions 31, 33, and 35. So let's look at 31. It says a sample of gas has an initial volume of 5.6 liters. So V1 is 5.6 liters at a pressure, P1, of 735 millimeters of mercury. If the volume of the gas is increased, so it's our new volume, to 9.4 liters, what is its new pressure? P2. So I have a volume and a pressure, another volume, and I'm looking for a pressure. Which of these equations has that? This doesn't mention temperature. This doesn't mention the moles of gas. So I'm definitely going to be using P1 V1 equals P2 V2. By the way, pressure and volume are inversely proportional. That means if I increase my pressure, I should decrease my volume. If I decrease my pressure, I should increase my volume. So if I increase my volume, I should get a smaller number for my pressure, right? So pressure and volume are inversely proportional. So let me plug in these values. P1, 735 millimeters of mercury, times V1, which is 5.6 liters, equals P2, which I don't know, V2, 9.4 liters. If I solve for P2, I'm dividing both sides by 9.4 liters. Liters are going to cancel out. I'll be left with millimeters of mercury. If I do this math, I'll get 735 times 5.6 divided by 9.4. And I get 437.87, or about 9. So 437.9 millimeters of mercury is P2, and guess what? That is a decrease in pressure. And so that is what was predicted. Pressure and volume are inversely proportional. So if I increase my volume, my pressure should go down, and it did calculations-wise. Let me do another example using any of these equations. It says a 48.3, I have to move this camera down a little bit. It says a 48.3 milliliter sample of gas in a cylinder is warm from 22 degrees Celsius to 87 degrees Celsius. All right, so a couple of things. We have a volume. Milliliters is volume. And you don't have to change milliliters or liters or anything like that. The only problem is degrees Celsius. So V1 is 48.3 milliliters and is warmed from 22 degrees Celsius. 22 degrees Celsius plus 273, so 22 plus 273 give me 295 Kelvin. And it's going to T2, 87 degrees Celsius, plus 273. So 87 plus 273. I get 360 Kelvin. And I don't know what my V2 is. It says, what is its final volume? So again, I look at any of the equations. All of these equations come from section 6.3 and they have different names. For volume and temperature, I'm going to use Charles's law. So V1 over T1 equals V2 over T2. And remember, T must be in Kelvin. So I'm going to use V1, T1. I don't know V2. And I have T2. So V1 is 48.3 milliliters over 295 Kelvin equals V2 over 360 Kelvin. Now, side note, my temperature went up. Volume and temperature are directly proportional. Basically, everything is directly proportional except for pressure and volume. So volume and temperature are directly proportional. And so because of that, if I increase my temperature, I should increase my volume. If I decrease my temperature, I should decrease my volume. Well, I increase my temperature, so my volume better increase. If I want to solve for V2, I could multiply both sides. I could crisscross and or I could multiply both sides by 360 to get rid of this. Or however you're going to do your algebra. Kelvin was going to cancel out. V2 is going to be equal to 360 times 48.3 times, my bad. 360 times 48.3 divided by 295, and I get 58.9 milliliters. And yes, that is an increase in volume, so this makes sense. Increase in V. So that makes sense. All right, I got 58.9. Or about 59 milliliters. Okay, so you might have some troubles with algebra and rearranging equations, but I'm going to leave that up to you or seeking more help from me. I'm not going to do this last one, but I'll set you up. It says a balloon contains 0.158 moles of gas and has a volume of 2.46 liters. So N1 is 0.158 moles and has a volume of 2.46 liters. If an additional 0.113 moles of gas is added, meaning my N2 is 0.158 moles plus 0.113 moles, at the same temperature and pressure, what is the final volume, V2? And so this is Avogadro's law, and I had this on the page before. Moles of gas and volume are directly proportional. So if I increase my number of moles, which I am, I should increase my volume. I'll leave it up to you to solve, but if you do this correctly, you should get, let's see, point. I'm doing it on the side for you to check your work. Okay, I'll leave it up to you to solve it, but if you do this correctly, you should get, I'll just do it. So we have N1 over V1 equals N2 over V2, okay? And I have 0.158 moles over 2.46 liters equals, I added these two together up here, 0.271 moles over V2. Now, I would cross multiply and divide in doing something like this. I would do 0.158 V2 equals 0.271 times 2.46, right? Just mathematically, if I have two fractions that are equal to each other, you could do cross multiply and divide. Cross multiply and divide. And so I got to divide. I got 158 over 0.158. V2 should be 0.271 times 2.46 divided by 0.158. And I get V2 is 4.22 liters. And now this number makes sense because moles and volume are directly proportional. If I increase my moles, I should increase my volume. And I got a number that increases my volume to 4.22 liters. All right, so I'll end this video here. You could just use this to do exercises 31 through 35, but that is how you are going to be answering these questions, knowing these equations at the top of the page. If you need any other help or work, this is more just plugging and chugging into equations, but let me know, and I could definitely help you with further work and practice on using any of these gas law equations up here in purple.